All right, so we're going to move on from inductive reasoning and we're going to start talking about something called conditional statements. Conditional statements are if-then statements, so they're if-then statements. And you may sometimes see them written where somebody will say they're an if P then Q statement, and we'll talk about that in just a minute and you'll see what it means. The way you may see it written symbolically is P implies Q, and we would say if P then Q. So don't get too caught up in it right now. Let's just write it down and we'll move on to some examples that'll make a lot more sense. The hypothesis of an if-then statement is the if part. Okay, it's always going to be represented with the letter P. The conclusion of an if-then statement is always going to be the then part. And again, just write it down. So we're going to move down and look at an example because that's the easiest way to understand these. A conjecture from your inductive reasoning can be phrased as an if-then statement. It helps you explain things that depend on other things. So we'll do a quick example. We're going to identify the hypothesis and conclusion of each conditional. And so remember, a hypothesis of an if-then statement is the if part. So if today is Thanksgiving Day, well, today is Thanksgiving Day is our hypothesis. Our conclusion, then, today is Thursday. So our conclusion is today is Thursday. So just take a minute and let this kind of sink in what we're doing here. A conditional statement is a statement that has a hypothesis and a conclusion. The conclusion is dependent on the hypothesis. So when we say if today is Thanksgiving Day, then today is Thursday, this part, the today is Thursday, kind of depends on it being Thanksgiving Day, because if it wasn't Thanksgiving Day, there's no guarantee it's Thursday. But since Thanksgiving Day always falls on a Thursday, this is a safe bet. If today is Thanksgiving Day, then today is Thursday. So we're just going to practice this a little bit. I'm going to go on to another one. A number is a rational number if it is an integer. So our hypothesis is the if part. It's the part that affects the other part. So if it is an integer, then a number is a rational number. Now when we write these out, it's a little trickier because our if part came second in our sentence, but that's more a English class kind of thing. That's just the way we wrote the sentence. It doesn't really matter. The if part is still the hypothesis, even though it didn't come first. So our hypothesis here is that it is an integer. Our conclusion is a number is a rational number. Okay, a couple of ways that you may see this if P then Q stuff written. And let's go back up just for a second and talk about all the if P then Q stuff. So when you're writing down these long conditional statements and you're writing down the hypothesis and you're writing down the conclusion and you're doing it over and over and you're doing lots of problems and lots of proofs, it gets boring and it gets tiring. So one thing we can do is, remember, our hypothesis is represented by the letter P and our conclusion is represented by the letter Q. So instead of writing today is Thanksgiving Day, I know that's P and I know this is Q. So if I was going to use these over and over in a problem or a proof or long paper that I was writing about something, I wouldn't keep writing them out. I would just write P and Q, and everybody would know what I meant. So a number is a rational number if it is an integer. Well, it is an integer is our hypothesis, and rational number is our conclusion. And so it kind of works out the same way. We write the hypothesis, that's the P. We write the conclusion, that's the Q. You can ask your parents about this. If they ever took any classes on logic and reasoning, they'll probably remember this, and they'll probably tell you it's either really, really fun or probably the opposite of that. But either way, the phrase if P then Q can be stated other ways. One way that you might see it is the way that I showed you back up at the top. You might see if P then Q. Another way you might see it is P, this little symbol, and Q. And that just means the same thing. If P, then Q. You may hear somebody say P implies Q. Okay, so maybe you'll hear implies. But it all means if P, then Q. And the last way you might see it represented, which is kind of hard to think about but makes a lot of sense, is as a Venn diagram. So you may see Venn diagrams like this, and all we're saying here is, in this one, if something is in P, then it's in Q. And so you're used to Venn diagrams, and we'll see some examples of that in our actual work we do. So we're going to continue practicing this. I know it seems trivial, but I promise you it's really important. So write a conditional statement from the following. So write a conditional statement. An obtuse triangle has exactly one obtuse angle. So if a triangle is obtuse, then it has exactly one obtuse angle. Okay, notice I changed my colors because I recognize that if it's an obtuse triangle, that's my P, that's my hypothesis, then has exactly one right angle. That's my Q. That depends on the P. All right, so we're going to move down and we're going to talk about related conditionals. Those are statements that are similar to conditional statements, but they're different versions of it. So a conditional statement is a statement that can be written if P then Q. A converse is a statement that can be written if Q then P. And remember, the symbols for conditional statements said if P then Q. So the symbols for converse will say if Q then P. Okay, an inverse says if something is not P, then it's not Q. And the way we'll see that written is with a little squiggly line. And that means not P, then not Q. And the last one is called a contrapositive statement, and that one, if you might have guessed already, will say if it's not Q, then it's not P. So not Q implies not P. And all we're going to do is practice rewriting a statement. In fact, why don't you practice rewriting it? I want you to take this statement that says if an insect is a butterfly, then it has 4 wings. I want you to write, and I'll help you out for a second here. An insect is a butterfly, P. It has 4 wings, Q. So you're going to write the converse, which says Q implies P. You're going to write the inverse, which says if it's not P, then it's not Q. And then you're going to write the contrapositive that says if it's not Q, then it's not P. So go ahead and rewrite that and we'll go over it tomorrow and make sure you got a good handle on it.